Hello everyone! Have you ever dropped a glass and watched it shatter into a million pieces? But when you drop a metal fork, it just clatters or maybe gets a small dent. Why is that? Today, we're going to explore the fascinating property behind this difference, brittleness. So, what exactly is it? In simple terms, brittleness is a material's tendency to break without much warning or deformation. When a brittle material is pushed or pulled, it doesn't stretch or bend very much. Instead, it just snaps. Think of a dry twig. You bend it a little, and it breaks cleanly. This is the opposite of a property called ductility. A ductile material, like a piece of soft metal wire, can be stretched and deformed a lot before it finally breaks. The reason for this difference lies deep down at the atomic level. In brittle materials like ceramics or glass, the atoms are locked into a very rigid structure. When you apply a force, there's nowhere for these atoms to go. They can't slide past each other easily. So, instead of bending, the bonds between the atoms just break, and a crack spreads through the material almost instantly. You see brittle materials everywhere. Concrete sidewalks, ceramic coffee mugs, and even the silicon chips in your phone are all brittle. An interesting thing about brittleness is that it can be affected by temperature. Many materials that are tough at room temperature become brittle when they get very cold. A famous example is the steel used in the Titanic's hull, which became much more brittle in the freezing waters of the Atlantic. Now, a common mistake is to think that brittle means weak. This isn't true at all. A material can be incredibly strong and hard, but still be brittle. Take a diamond, for instance. It's one of the hardest substances known to man and can withstand immense pressure. But, if you hit it with a hammer at just the right angle, it will shatter. Its strength is high, but its resistance to fracturing under a sharp impact is low. So, brittleness isn't about a lack of strength, it's about how a material fails when it reaches its limit. It's the snap, not the bend. Thank you so much for watching. If you found this explanation helpful and want to see more content like this, please give this video a thumbs up and consider subscribing to the channel. Your support means a lot and helps us create more videos. See you next time.